when we start a project for the machine learning or basic machine learning project, like we need some algorithms, and we should set or we should choose the cost function or the utility function of that machine learning algorithms do. And after just applying them, and we should have some measures to check or to evaluate the performance of the machine learning. And this is the core issue, or this is the core thought behind every machine learning. Whatever it is supervised learning or whatever it is unsupervised learning, the basic insights or the basic thought behind them, it just these three parts. And after you just learned how to apply a machine learning algorithm in this lecture, and after that, you just need to replace with another new machine learning algorithm in you wanna apply. And you should learn something about uh, under what kind of circumstance this kind of machine learning will be applied. This is a knowledge you need to learn by yourself, and the model or the framework of the data mining will be shown in this lecture. When during this problem to search the new machine learning algorithms which is created for them. Okay. When we are starting the machine learning, the initial thing for us to do is to make a training data set and a test data sets, which means that we should do a divisions. We should do a division on the original data sheet we have. And also you can search, or you can just search new data, and you can just supplement them into this data sheet, and this are okay, because you can just rerun this work, you can just rerun this project after the new data are supplemented. So for us now we should need to do division, and you can use the chain test split. And in but before that, I have just I have just found the features values in this datasheet, because when I'm doing this work with a group a long time before, and all the like they have choose this this dioxide to be the feature value. So it's the terms you, or this is the term you should get accustomed to, the feature value, because it will be seen as X. And the Y value in this data sheet is the phase 3 plus and over phase TOT, phase total. And it's the corresponding label value. So the job for some is quite common for the supervised learning algorithms to do is to build the relationship between the feature value and the corresponding label value. And mathematically, it will be shown as a formula. And maybe they will just be a complicated formula than you imagine. But the basic linkage behind them is just to build a bridge on the just build a bridge between X and Y. So you need to find what the feature value you wanna use, and you should find the corresponding label value. And it's okay for you to put them into separate data sheet, but I just put them on the same data sheet. So for me, I should to divide them manually. Like when I use the job method, I create a duplicate. And also I let the y be this column. Now for us, we need to get the training sets and testing sets. Why is so important? Because as I have mentioned that we need to evaluating the performance of the machine learning algorithms. So how can we do that? Because it's just like a machine. You can just have a feeling on that. When you just feed the machine with some data, with some specific data, and then it will learn, or no, it's just baby when it's learning some knowledge from outside, and you will just construct its cognitive, it will just construct his cognitive on the real world. And then when it just gets into a new environment, and you will use the experience, or it will use the knowledge he has learned before to get judgments on the new circumstance. So which means that training sets will be representing for the training set will be representing for the old experience, and it's the old data you use to feed the machine, or you use to train your baby. And the testing sets will act as like the new data or the new circumstance, and you should use the testing sets to evaluate the score, or to evaluate the performance or the machine learning generalization abilities. And always they will be seen as the score of some mathematical term. Okay, and now we should check the dimensionality of the training set we have. Like this, you can see for the X-chain. X-chain means is the feature value datasheet in the training sets. And you can see the number of the samples we have in this sheet, 312. And also the dimensionality, the dimension of this of this training set, 60, which means that it's which means the summation of this column, or the total number of this column, is 60. And you can check the dimensionality of the Y chain, because in case that maybe sometime you will just mismatch the prediction of the X test or Y test. Maybe you will just name this Y test, so you should check, because the order should be replaced correctly, because the function has been set. Okay, so in case that something terrible happens, you can check the dimensionality by the attribute shape, and it's the terminology inside in the Python. Usually you had the class, and we have the function, and inside the function or inside the class we have the methods, and besides those we have the attributes of the method, or we have the attribute of the function, and you should get accustomed to those terms. And now the job for division has been done already. And here, these codes are read. These codes are read, or it's just a strategy for you if you just acquire getting accustomed, or you're accustomed to the cycling, because you can use the pipeline to build just a pipeline for the numericals. You can just to do a pipeline for dealing with the numeric value, and also you can build other pipeline for non-numeric value, and you will just work as smart as possible. And so it's a higher strategy after you get used to it. So then we will just go step by step to explore how they work respectively. Okay, now for us to do no, before that, imputer here means the method, or imputer, simple imputer is the functions used for dealing with the missing value. And you can just fill them with the value in each column, or you can just fill them with the maximum value or the minimum value also. And you can fill some values, or you can fill some numbers you want by FillNerd. I have just put them before, FillNerd. And the standard scalar is for the standardization, because every column has its magnitude. Like we can see here, uh, for the SiO2, wait, we can see that almost every number is above 40, but for the ZNO, it will just concentrating beside 10. So they are totally different, and it's quite sensitive for the machine learning algorithm when they are dealing with these features, because they have various like magnitude, and so it will affect the performance of it. And I think the statistic group has just tell some techniques to do the to deal with the scaling problem. And this one of the function you can use the standard scalar in Python, and you can seek other, or you can browse other functions in Python. And don't put them I don't just list all of them here. I just put some of the examples to help you understand and help you grasp the knowledge related on the machine learning or on the data mining. Okay, this is the uh primitive work we should do for training the machine learning algorithms. And now we will strive forward. We will step inside some specific machine learning algorithm. And in this lecture, we will focus on the most simple one. But simple doesn't mean that it's easy to learn, because its derivative of its spin-off will be just a huge treasure for you to explore. And we will start with the most easy one, the linear regression. And I believe that all of you guys have learned when you are in the freshman in the university as a freshman. Okay, uh, I should just nip a word. Okay, as you can see now, all of the functions are quite easy to use because they have packaging already in the scikit-learn packages. Scikit-learn, you can call it scikit-learn or scikit-learn, and that's okay. And you just use the from scikit-learn linear model import linear regression, and you can use these machine learning algorithms. And you just need to feed them. Feed me, or you can feed them, or you can feed, just like you throw the food to your baby. You can feed them. feed them or feed them. And the linear regression model is easy because the mathematical formula, is quite understandable. Because as I put it here, x1 mean x1 x1 means the features, each of the feature, and x2 means the second column of the feature set we had before, and the a stands for the weights. We call it weights. And here, x means features, and the last term b means buyers. So now we can start with these simple machine learning algorithms, because for the machine learning algorithm, it will try to find the weight and the buyers it would be through the data set you feed them, the features you feed them, the training set just like the features, and they will learn by themselves to find out what weight they should be and what buyers it should be. And the formulas are shown here, quite simple. So for us to learn is to find a specific algorithm. And this is the logic behind this code. And we will learning the code. Also, we will learn the knowledge together. Now, for you, you just use this function and then you just feed them with the, you should feed them with the feature value in training set, and you should feed them with the label value in the training set. Why we should do that? Because it depends on the cost function. We can call it cost function. So if not only do you need to fill with the X, but also you need to feed them with the Y, with the corresponding Y. Because for them, for our machine learning algorithms, it has some methods to find the real weight and real buyers through the data set. How can they do that? Because they will use some math methods, like in the linear regression, we have two ways to train, and we have two ways to deal with. The first one is quite a normal one. You can call it alias, the least square method. And it is a direct closed form equation. And the job for the parameters, it should minimize the cost function. And this works for almost every supervised learning algorithm. Even for some unsupervised learning algorithm, it works too. So for us, we should know why we need the cost function, because we should find the weight or the buyers which minimize the cost function over the training set. This is the job of our machine learning, the job for our machine learning to do. Now, for a because I have done for the linear regression. The first way is the normal equation, also named as least square equation. But it will be just computing. It will just cost you computing resource dealing with this matrix. Even if you think they are simple and they are clear in the math formula, but when you dealing with this matrix, it will cost you a bunch of computing resources to do. Even if you use some other mathematical method like the singular value decomposition, maybe you learned when you have some math class before. And the second way for you, no, the second way for the machine learning to do for the linear regression to use is the iterative optimization approach. And the common way for that is the gradient descent, because sometimes you cannot directly get the result. The result is the value of the weights or the results of the value of the buyers. So sometimes it's not directly enough. So we will seek another way to just make some charts on them. Like the gradient, if you are getting used to just the common term used in physics, because gradient and the divergence and like the another term I forgot, sorry. And the gradient represents the directions of the parameters goes fastest. So beside these linear regressions, why we need to feed them? Because it's to should find the minimum function. When it reach that the minimum, and the corresponding parameters will be the ways or the buyers we want to seek. So for it will just tweak the parameters iteratively, and it will just measures the local gradient of the arrow functions with regards to the parameter vector theta. This is the symbol for the gradient. And it will use some knowledge about the calculus and it's a partial derivative and some basic knowledge about the algebra too. And it's simple to understand, and you can try to find how it works beside this code. And why is so important for us to know? Because most of the machine learning algorithms are built on this approach, gradient descent, and it's a derivative, especially in the neural network, and you may wanna apply later the ANN artificial neural network. It will use the gradient descent to do the back propagation, of a word propagation, backward propagation. And also, after you learn the basic framework of every machine learning algorithm is useful, you should learn what is the best or what is the certain circumstance these machine learning algorithm should be applied for. So this is why we need to know the basic knowledge or the math knowledge behind them, because it will help us to understand what's the intrinsic quality the machine learning algorithms has. Okay, so we can go on the we will just find the weight and the buyer after feed is the X chain and Y chain for the linear regression. And it will just compute them in the blackboards. And you don't need to know how it works beside it. But the math knowledge it used is just put on the right document here. And it will just find out the coefficient, and we mean the weight here, the coefficient, and you will find out the intercept, and we can see the bias. Now we have trained a linear regression. We have trained a machine learning algorithms, and we can use trained algorithms for new data set. And the new data sets comes from the division we said before. The test. Test means new data set, means new data set for evaluating the performance of these algorithms. Now it's quite simple to use also, because you just need to use the predict functions, and you just put that variable you have made for the testing set, especially for the feature value, because it will make its own prediction on the feature values to calculate what the corresponding label value means y value it. So the prediction we have now, which is made by the linear regression, is the y-test prediction. And here shows the prediction result. And what is the real value? Because we know all of the data has been tagged before, has been labeled before, because we have those real value in the original data sheet. But under this circumstance, we think those testing sets we defined before as unknown data, which is why it is called supervised learning, because we use the data we have already know as unseen data. We just simulate a circumstance, a new circumstance for the machine learning algorithm. This is the magic behind this. And this is why we should do the work for dividing. So the next step for R is to evaluate the performance. So how can we do that? This is the final round for us to do for our machine learning algorithm evaluation. So we should find some performance measure. Like it's quite a common one, and maybe you use them in your work already before, like a mean square error. It will find the difference between the prediction value and the real value. And you can use another performance measure like the root mean square error, or R2, and it's quite common, and which is one of the common performance measures you have. And you can use other ones if you have idea on them, and that's okay. So, and also so that's the cost functions, because the cost function here, it used the MSE to find out the parameters itself. And if you are getting used to the meaning of the calculus, and you will know what it represents for in this formula, and what is physical meaning it is. So now we have just gone through a complete circle of the machine learning, and we can use the matrix inside the scikit-learn, like the mean square error, and we should calculate the difference between the y-test and y-test prediction. And this is the score reflects the machine learning algorithms generalization ability. And you can use other scores.
What is a good value for the evaluation? Below what should be the absolute error?
It's hard to say. Actually, it's hard to say because it will depend on your empirical experience. So really hard to say. And you should make some comparison with the work done by other guys and or other articles before. You should find some relative value or related tipping points you think they are suitable for you to think as their evaluation performance. No absolute right or no absolute fault. So it up to you and is up to your experiment. And also you find the suitable matches. And it's also critical for every machine learning algorithm because they has different matches to evaluate. And you should not or apart from the matches, you should find some specific values to as some like the baseline. So let's move on. Now it's questionable to see that one or whether it will be just a typical or whether it will be the typical performance for a machine learning, especially you just have a you have just have a one chart, and this is not enough. So we should use another method, or you should do it repeatedly to find out the general performance of the machine learning algorithm. And it's quite important too, because one success doesn't mean that it will always success. So there are some functions we can use in the cycle, like the cross validation. So how it works as cross validation. Here, the cross validation, when you fit them with the data set, you just replace them with other data set. And but you should make sure you have feature value and the label value and the models you want to use, and you should set the corresponding scoring. And now you can see what's behind that. Here is the total data set, and it will randomly, and maybe you can set some strategy like stratifiedly, and they will divide the total data set, like the exchange data set, into five experiment, into five or into five folds. We call it fold here. Like how we set it's five. CV is equal to five. So it means fivefold. And you will do some random splits on that data set. Here is the first fold, second fold, third fold, and also others. And it will see the first fold at the beginning as the validation set. Validation here means the testing set. And we can talk that later. And here, validation means testing. So it will see the validation or test or the validation as testing set, and it will use the rest of the four folds to train the linear regression, because it's the variable we have put that before, linear regression. And then it will judge it basing on the scoring the mean square. Because it's the problem of the function, all of the scoring will be called as negative. So you can just use a negative symbol to just to make them positive. And that's okay because we just compare the like how big or how small they are. So whether it's positive or negative doesn't count a lot. So the first step for it to do for this cross-fail score to do is to use the first testing set and then go again. It will run again. It will see the second fold as testing You can see the more deeper color one. You will use the in the experiment 2, it will use the second fold as the testing set, and it will use the rest of the 4 folds as the training set. And then iteratively, after doing 5 folds, after doing 5-fold cross validation, it will give you a scores. I have shown them here, the scores. These scores are calculated based on the mean square error, but I just make a square root and put a negative symbol, and this score stand for the root mean square error. And now you can see the results of this cross-fail score. So in the experiment 1, the machine learning algorithm scores is 0.4. And in the second round, it's 0.4114. So it's unstable, but you can set this high. And if you use a data set, so it depends on the quality of your data set, whether they qualify enough to represent the common attributes of this data set. Because there are too much noises inside the data set you collect. So the purer the data set is, the higher quality, the higher performance you will get on the machine learning algorithms. And you can see the difference between them. So this is the result of 5 folds, and you can set 10 folds, and that's okay. And and then I have built a function to calculate, like use the mean measure, and you will calculate the mean scores of these 5 scores. And you can find the standard deviation in these 5 scores also. And it will kind of measuring the accuracy of the assessment, because you know the fact of standard deviation. And I would not shed too much explain on that because it's some basic statisticity knowledge. Okay, and now we have gone through a complete machine learning application, and then we will just move on to a new complex one, which is polynomial regression. So for the linear regressions, usually we will use them for the linear data sets, which means that the relationship if they are, and in this way linear regression will work